What's poppin', dogs? Mr. Allen here with some solving of systems of linear equations using substitution method in this video. So we do have three ways to solve systems: elimination method, substitution method, and graphing. My preferred is elimination method. So if I have the choice, I'm usually going to that one. But if you're required to use substitution method, and usually when you first learn how to solve systems, they're going to require you to show each way on a test, you're going to have to do it. All right. There are times that where substitution method makes sense. Like this first one right here, I have y equals x minus 7. I can easily take this guy right here and plug it in for that y right there. So I'm going to have 2 parentheses x minus 7 plus x equals 4. So I took what y equals and I substituted it, hence the name, in for y, and now I have an equation with just x's, right? There's only x's here. So now I can just go about my merry way of solving a linear equation in algebra, distribute the 2. Yay! I get 2x minus 14 plus x equals 4. Combine like terms. 2x and x, that gives me 3x minus 14 equals 4. Add 14 to both sides. Woo! This is awesome. 3x equals, what was that, 18? Divide by 3. I get x equals 6. And you're like, bro, that was so cool, I'm done. You're not done, okay? We're not done yet, man. We're halfway there, like that song. Oh, we're halfway. Anyways, I was on tour with them, so my voice is just shot, so I got to rest it. Got to have some, some tea, lemon, stuff like that, repair it, and then I will sing for all of you. All right. So I've got x. I got to get my y value because the solution to a system of equations is the intersection of two lines. If I got two lines and they intersect, that point right there is the point we're trying to find, which in this case currently is 6 comma something. Finna about to find that something by plugging in 6, okay? So I'm going to have, let's see here, y. This is perfect. I already got one for y. Y equals 6 is going in for x. Anytime I do substitution of a value in for a variable, I usually throw it in parentheses. In this situation, it really doesn't matter, okay? Because there's no coefficient here to multiply to 6. There's no exponent. But in the event that there was, I usually just start doing that as like a best practices thing. I throw it in parentheses. It shows that I'm substituting. Yay, math. All right. So y equals 6 minus 7, which is -1. So y equals -1. So my answer here is 6 comma -1. Got to erase that. Doesn't erase very well on here. Boom. Solution, right? It's an ordered pair, a point on a graph, 6 comma -1. That's where these two lines, if they were graphed, would intersect. Cool? Move on to the next one here. Unfortunately, this bad boy right here, I'm going to go blue actually, is not yet set up for substitution. But there is a variable that's pretty easy to solve for in one of my two equations. You get to just pick, right? You could go for the first one there and deal with some fractions. I wouldn't suggest it. Pick the one that's easiest to solve for a variable, isolate a variable. So I'm going to have x, I'm going to add 2y to both sides. So I'll have x equals 2y minus 4, okay? X equals 2y minus 4. I've solved for x in terms of y. You'll often see that wording on a piece of paper, directions, whatever. Solve for x in terms of y. That's what that means there. I've solved for x. My answer just has y in it. And now I can take this and I can plug it into this equation up here, substitute it in for x. So here's what we're going to have. It's going to be a bit long here. We got 2 parentheses, 2y minus 4 goes in. I'll even do that in green here. 2y minus 4. Close it, plus 5y equals 19. And look at that. We have an equation here with just one variable, which I can solve using all my fun algebra skills that I know and love, right? Solving a linear equation at this point. Boom, boom, or a single variable equation. I got 2 times 2 is 4y, minus 2 times 4 is 8, plus 5y equals 19. I'm going to combine my like terms. 4y, 5y, that is 9y equals, let's see here, minus 8 equals 19. Then I'm going to add 8 on both sides, and I get 9y equals 27. Then I'll divide by 9, and I get y equals, I'm going to tuck it off to the side here, y equals 3. All right, so I got y equals 3. That's good. Now I need to solve for x. And if you're confident in your algebra skills. I'm pretty confident in my algebra skills. I do screw it up sometimes. Actually, just the other day, I made a stupid mistake. It happens, man. But I've already got x equals this, so I can actually use that. X equals 2. We're substituting in the 3 for y minus 4. Look at that. I already had this equation solved for x. Why not use it? You could use this one up here, but you already did it here, right? We're already all in on our algebra skills. Might as well use the thing that would make it easier, right? And I get x equals 6 minus 4, which equals 2. So my final answer here is x, which is 2, comma y, which is 3. Nice. This is x equals. All right, there we go. Again, solution is an ordered pair because it's the point at which these two lines intersect. What if they never intersect? It sounds like the next video that I'm going to make. All right. For now here, let's deal with ones where we actually have solutions. All right. Let's go with, I'm going to go orange. Let's go orange on this one. Orange, you glad I picked this? All right. Let's see here. All right. Nothing's easy to solve for here, except for the first one. Okay. All of these are divisible by 2 is what I'm seeing, right? Everything's divisible by 2 there. Let's go with that one, okay? And let's solve for y. So I'm going to subtract 4x, right? I'll write it all down here. We got 4x plus 2y equals 14. I'm going to subtract 4x on both sides. So I got 2y equals negative 4x plus 14. Divide by 2 on everything, and I get y equals, that's negative 2x plus 7. All right, we did it. Guys, we did it. It looked scary. It was terrifying. I cried a little, but we handled this situation. So now I can take that y expression, the expression that's equivalent to y, use my other equation now. We used the first one. That was a voice crack. Yes, I know. I'm leaving it in there. We used the first one, so now we got to use the second one. So let's go ahead and do that. I got 3x minus 5. We got equals negative 22. So let's plug this stuff in here. I'm going to need to uncap my marker for that. Negative 2x plus 7. Nice. And now I can algebra with this thing, right? I can distribute the negative 5. So we got 3x plus 10x minus 35 equals negative 22. That's 13x. I'm going to save a little time here, a little space here, guys. 13x. I can add this 35 to both sides, right? Negative 22 plus 35, that's 13. Well, that works out very well. It's almost like I planned it. Divide by 13. I get x equals 1. Nice. If only there was an easy way to figure out what my y value is. Oh, wait, this guy right here. It's already solved for y. Why not use it, right? So I'm going to take this other marker here. We got ourselves y equals negative 2, parentheses, 1's going in for x, plus 7. So that's negative 2 plus 7, which is positive 5. So y equals positive 5. And my ordered pair, my final solution here, hopefully we can see it on the board, 1, comma, 5. Dopeness. Let me check my little watch here. We can see it. Excellent. Fantastic. Wonderful. Once again, answers are ordered pairs, x comma y. Substitution, definitely a valuable method, especially later on in mathematics. Substitution actually makes a good comeback. All right, and it's helpful in certain crazy situations like pre-calc honors and stuff. That's a ways off for you guys, all right? For now, if it asks you to use substitution method, you got to use it. If you're set up in a situation like this, why the heck not use it? I don't even know if I'd bother with elimination on something like this guy. It's so convenient to use substitution there. But there we go, guys. Hopefully that helps. Hopefully you enjoyed it. And if you did, like it, subscribe it. Watch more videos. See you later.